Now this entire build cost, alright, I've been trying to get the cost under 1,000 US dollars. And I think I've pretty well achieved that. It's around about $1,000, maybe $50 either way. But for that you have a pretty substantial little CNC router that you can do a hell of a lot of projects with. So I'm going to start putting the limit switches on, and then we will set the limit switches up in the controller. And the next stage then is to tune the motors in to get them working really accurately, cutting very accurately to within a couple of thousandths of an inch, or 0.01 of a millimeter. Should be able to do that okay. Okay, so what I'm doing now, I'm deliberately taking the axes to their hard limits. In other words, as far as they'll go, because I want to because I want to see what the travel is exactly, and so I can work out what to set the soft limits at after I've got all the limit switches all set on here. So that's a hard limit, okay? When it starts making that noise, that's as far as it'll go. So now I'll take it all the way up to the top. And there's the hard limit at the top. So it's got quite a long travel. It's about 100 and... let's measure it and find out. It's exactly 140 millimeters, which is... ooh, what's that? 5.5 inches of Z travel. Pretty pleased with that. That's okay for a small little machine like this. We're really going to be able to do some work with this, and I suspect it's around about 400 in the X travel and another 400 in the Y travel, because I do know, and I purposely made it this way, that the X and the Y axes are identical. You can take this off here and put it on here if you wish, because it's a modular unit. I've designed it to be modular because it makes it all easier to make. Makes it easier for you guys to make one. And of course all the drawings and specifications are available on my Patron pages. But you must use those drawings in conjunction with the videos, because some of the measurements that I've actually done on here don't appear on the drawings, okay? But I talk about them, about the size of this material. It's all 10mm plate by 160. Although I do have those measurements on the drawings, but there are some measurements that I talk about in the videos, and I've purposely done it that way so it's easier to understand, and build one yourself. And you don't need any special tools to make this. I made this whole thing with a very rudimentary workshop drill press. As you'll see in the videos, I did, just to cut a couple of corners, I did use my CNC, my converted CNC mini mill to do some of the drillings where these bearings were because it was easy for me to do it that way. But you could do this just with, you know, a small drill press. I suppose you could drill it by hand, but that'd be difficult. But it might look complex, but if you follow through stage by stage of the videos and the drawings, you can make one of these for yourself. Right, also I've finished now putting all the limit switches on and connecting them up. There's one here, one here, one here. So now we're going to set them up in the controller so they work. Okay, so it's very easily done. So you go to machine, okay, home, okay. So we need to come here now and change this 0 to 1. That switches them on. A couple of other things we need to do as well. And incidentally, these are the pin numbers that you put into the back. Like Z would be pin number 13, Y is 12, X is 11. I've already done that. Right, so hit that so it goes green, press 1, and then OK again. Log that in. Green, 1. Okay, goes to red. Okay, 1. Okay, goes to red. Okay, now on the way back, I'm going to change this number here. Now this is the rebound or the back off. So when the axis comes up and triggers the switch, this is the amount that's going to back off from the switch. 20 millimeters, a little bit too much for me. So let me see. I'm going to say I will make it 10 millimeters. That'll be okay. And again here, 10 millimeters. Okay. And 10 millimeters. And when you do alter some figures in here, you must come down to save. And it's saved, you exit out of that. Now I'm just going to put my hand on the Y switch. Now you should be able to see it come up on here. There you are, up on 12. And the Z on the 13 and the X on the 11. So they're all functioning and the controller sees it. So I suppose the next thing to do would be home it. Okay, so I've just finished putting the limit switches on the 3 axes, and I've filled the information out in the controller for this MIDI CNC router that I've built. And if you filled it out correctly, and I will show you how to fill it in a few minutes, and which buttons to press and what does what, you should have a little CNC router or mill that will home itself and know what to do, same as what Mac that you would in Mac 3. And to get it to go to its home position or find its home position is very simple. You press that button there, reference coordinates, and press OK. There you go, it's done. So really happy, everything works, you know, first time. as it should. If you download the manual off the internet for this, obviously it's written in, well, not very good English, and the symbols are still in Chinese, so you sort of have to coordinate the English symbols on here when you've changed this to English, which I showed you I think 2 videos back how to change it to English, and then relate it to the manual. And also the manual talks, well, you know, the term Chinglish, well, it is, but you should be able to decipher yourself, you know, sort of what to fill in to suit your machine. This one is you know, I filled it to suit my machine, and I will now zoom in onto the screen and the buttons of this, and I'll show you what I've done to make this operate. Like I say, you can follow the manual if you're prepared to sort of, I suppose, think Chinese. Okay, here we go. So what I'm going to show you first, if you press a button and you're in the screen and you're not sure what it is or how to get out of it, just press escape. That takes you back to the opening screen. Now what you should be looking at first is, first of all, whether this is in Chinese. So you go to this second window down. Alright, you can either press OK or press on that button, but you can press OK, and this is your selection wheel, and the English section is actually written in English. So if your panel is in Chinese, you just come up here, press that, all goes to English. So now this is set for my particular drivers, motors and machine, and lead screws. So what you should probably go to first is motor, the motor settings. Now the settings for the motor will be, as you see up here, 320. Now that's just a general setting. Now I found out with mine, the actual settings for my stepper motors and my particular lead screws is 400 steps, and also the velocity was just a little bit too fast. I can speed it up later, but you know, I like to start things quietly. So if you find your axes are moving a little bit too fast for you, just drop the velocity down. Now it was set at 3000, I've dropped it down to 1000, and you can see how quickly it's moving. It's quick enough. This one here, steps per 2, this is a ratio. Okay, so if I had each of these stepper motors like belted up 2 to 1, you would put 2 here, or if it was 3 to 1, you'd put a 3 here. So you're just telling the controller that, you know, how you're set up mechanically. Okay, so this is electronically, this is mechanically. Obviously we've just spoke about the velocity. Acceleration 200's pretty, it's okay. So this one here, direction low active. Now I have to change mine. Now 0 is high and 1 is low. Could be the other way around. Anyway, this just changes the direction. If I put this as a 0, that would make it anti-clockwise, and I needed it clockwise to be able to home going up, because the Z you home in the top of the stroke. Stepper timer. Now this is a number between 0 and 5. Now this is the in milliseconds. Now I've always left it about 3 midway, and I've never had any problems, so I would advise to do the same. So really that's all you need to do for the moment to set it up. This is probably not perfect yet, but I have to, what I need to do there is, and that'll be the next video, is tuning the motors into an exact measurement. Okay, so you know this is close. It could be, you know, sort of, it could be 10, 20 thou out, not sure yet. It's close. I've measured the travel of 130 millimeters because that's what I've got in my X travel, and it roughly coincides with what the DROs, the digital readers, are reading. So, you know, I'll get a DTI gauge out and we will do it properly on the next video. So that's okay, so we can leave that. Now then, homing and limits. No, not that one. Okay, so you go to the homing screen, and what you need, you actually need to go here first to find out which pin, input pin to connect up to. It's already laid out here, 11, 12 and 13 in the back, which I've done. And to enable it, you just change it from a 0 to a 1. So that's all okay there. This is the direction of homing. I understand. Everything works fine, as you just saw. So everything's fine there. This is for your probe. This is the retraction speed, axis mode. Not quite sure what that is, but it should only be on the Z axis. Probe speed 100 millimeters per minute, that is. And this is the back off length. In other words, when it comes down and touches your probe, it'll back off 10 millimeters. And somewhere, not sure where yet, we'll get to it together, probably in the next video. We have to put a measurement of our actual probe in there, so the controller can actually sort of subtract that out of the final measurement. So really that's all you need to do there. So we'll come out of that. Okay, so we're going to go to soft limits now. There's a couple of things to remember here. Obviously you've got to enable them by changing the 0 to a 1. Now, of course, this figure here, now that is the actual length of travel that I have, which is 130 millimeters in the minus direction, all right, because the x-axis homes at the top of the stroke. So the length of travel you're telling the controller is 130 millimeters, but okay, soft zone. So you're telling it that you're allowing it to travel 125 millimeters before you want the soft limit to come on. You know, you can alter that figure as much as you wish. I believe that's the correct way. It's working for my particular machine. I did actually put in there, well, I wanted 5 millimeter soft zone, and it only actually moved the axis 5 millimeter before the soft zone came on. So I figure it's that, and it appears to be working just fine. Of course, in the Y and the X, you're moving in the plus direction, so that you feel it. I've got actually 395 millimeters of actual travel, but I've said I want the soft limits come on at 390 millimeters, and of course I've enabled both of them as well. Oh, here's an important one. This is a machine limit, okay, not a work limit. So you need to change this little window to machine mode, okay, to tell the controller, well, this is, you know, the operation of the entire machine, and these are your soft limits. So really that's that. And after making any changes, you must press save, and you'll come out of it, because otherwise the flash memory inside won't remember. So really that is setting the controller up. That's all you really need to do. Don't know why this is on, that T1 there, don't know why it's showing on. I may have inadvertently changed a setting to be either high or low somewhere when I was playing around with the controller. Can't seem to find out where that is, so you know, I'll find over the next few weeks what I've done there, but it doesn't stop the controller working. Another useful control here, and that is the jog window. Incidentally, you don't have to turn this wheel, you can actually select by doing this. Now if you okay that, what you're saying is, well, the next axis that I press, I want you to move 1 millimeter. And indeed, as you can see, it's moving 1 millimeter, or even you know, you can come down here. Okay, that one changes so it goes green, and you can see it's 0.1 of a millimeter, and so on and so forth. It's very, very easy to use. So it's you can move it very, very accurately, the same as you could with Mac 4.